So before we get started, this is a continuation of the two rocks in space colliding problem, part A. So if you haven't watched that, it is probably a good idea to do so. So this continuation is asking whether or not part A's collision is elastic or inelastic. And in order to do that, we have to analyze the initial and final states of kinetic energy before and after our collision happens. And then once again, we are given these initial values that were given to us from the problem in part A. So we have the masses of the two rocks, the initial and final velocities of rock 1, and the initial and final velocities of rock 2. The final velocity of rock 2 being what we solved for in part A. So, as I said before, in order to decide whether or not the collision is elastic or inelastic, we have to survey or analyze the initial and final states of energy. So, unlike part A, where we solved for the final velocity using momentum conservation, now we are going to be doing energy conservation. And this basically looks the same as momentum conservation, except now the equations we use will be not momentum equations, but kinetic energy equations. So we have the kinetic energy of our first object plus the kinetic energy of our second object. This would be the initial state before our collision must be equal to the kinetic energy of our first object again after a velocity change plus the kinetic energy of again the second object after a velocity change, and this would be the state after the collision. So unlike momentum conservation, we are going into energy conservation knowing all of our variables' values. And this is because sometimes energy is not conserved in a collision. Kinetic energy is not always conserved. And when it is not conserved, we can say that a collision is inelastic. So when the change in kinetic energy does not equal 0, or kinetic energy is not conserved, a collision is inelastic. So because we know all of our variables, what we're really just going to be doing is comparing the numbers that we get in the initial state and in the final state and seeing if they are equal to each other, and that will help us decide whether or not our collision is elastic or inelastic. So what we're going to do is bring this energy conservation equation down here and write in all of the numbers that we know. So let's actually do one big parenthesis here. For our first rock, 1/2 times 3,000 kilograms times the initial velocity, 20 meters per second squared, plus, and then this is actually going to just equal 0 because we know that the initial velocity of rock 2 is 0 meters per second. So that's just 0. Will be equal to, let's do another big parenthesis, 1/2, and then this is rock 1 again, so 1/2 times 3,000 kilograms, and then our final velocity was 10 meters per second squared, and then plus 1/2, and then rock 2 again is 1,000 kilograms times, and then the final velocity that we calculated was 30 meters per second, and then that is squared. So we just have to calculate these out and see if they equal each other on both sides, and we get that the kinetic energy for rock 1 initially is 600,000 joules, which will equal the final kinetic energy of rock 1, which is 150,000 joules, plus the final kinetic energy of rock 2, which is 450,000 joules. And very simply, we just add these two numbers together, and we get that 600,000 joules is equal to 600,000 joules. So after all of that, after the energy conservation, we can see that our change in kinetic energy is equal to 0. So the initial and final states equal each other, and our collision is elastic.